Some things shouldn't exist. A wooden pillar standing for 1,400 years. A Viking ship built from simple hand tools crossing oceans so violent that modern steel vessels fear them. And medieval houses, made from nothing but timber and sweat, still standing straight today, while your backyard deck begins to sag after one rainy season. How is that possible? Because the deeper you look, the stranger the truth becomes. Japanese carpenters built temples that survived more earthquakes than any modern skyscraper. Vikings coated their ships in a mysterious black substance that terrified shipworms and sealed out the sea. European craftsmen preserved wood with a mixture so effective that cathedral beams still look alive today. Meanwhile, you can spend thousands of dollars on a brand new fence, a pergola, or a wooden shed, only to watch it rot, crack, and collapse in a few short years. It's almost insulting. How could people with no electricity, no chemistry degrees, and no industrial machinery create wood that lasts centuries, while our advanced technology fails before the next election cycle? What did they know that we don't? That question sparked one of the most surprising investigations in materials science. Because when researchers dug into old temples, Viking shipyards, and medieval repair archives, the clues all pointed to a lost system, natural, safe, and unbelievably effective, that modern construction quietly forgot. And here's the twist. It's not one secret ingredient. It's an entire philosophy of wood preservation. One that doesn't fight nature, but uses nature itself as the shield. Today, we're going to uncover that forgotten system. And once you understand it, you'll never look at modern lumber the same way again. Before we uncover the ancient techniques that made wood last for centuries, we have to face a truth that most people never think about. Modern wood is born weak. Not because builders today are careless, but because the wood itself has changed. If your grandfather's old barn or fence lasted for decades, it wasn't magic. It wasn't luck. It wasn't even better craftsmanship. It was the material. The lumber he used simply doesn't exist anymore. Today's lumber industry grows trees the way we grow crops. Fast, cheap, and replaceable. A pine tree that took ancient builders 100 years to grow is now harvested in barely 15. And that speed comes with a cost. Young trees are mostly sapwood, the soft outer layer that transports water and nutrients through the trunk. Sapwood is full of sugars, moisture channels, and living tissue. For fungi and insects, it's the perfect food source. It's the biological equivalent of leaving out a bowl of fruit in the sun. Ancient builders knew this long before we invented microscopes. They waited for trees to mature because they wanted heartwood, the dense, dark, resin-packed core that forms only after decades. Heartwood is nature's armor. It is naturally rot-resistant, insect-resistant, and far denser than the soft sapwood we rely on today. But heartwood takes time, and time costs money. So modern forestry simply doesn't wait. As a result, most of the lumber you buy today is already vulnerable from the moment it's cut. To fix that vulnerability, the industry turned to chemistry and invented pressure-treated wood. On paper, it sounded brilliant. Put lumber in a vacuum chamber, suck out the air, and inject it with preservatives. For a while, it worked. The original formula, CCA, chromated copper arsenate, was incredibly effective because it contained arsenic, a powerful poison that fungi, insects, and even marine organisms couldn't tolerate. But the effectiveness of arsenic was also its downfall. It leached into soil. It contaminated playgrounds. It released toxic dust when cut. A single plank could contain enough arsenic to be lethal if mishandled. By 2003, the industry had to abandon it. The newer formulas, ACQ and CA, removed the arsenic. But to make up for the lost power, they increased copper levels dramatically. And copper, while less toxic to humans, is extremely corrosive to standard metal fasteners. Builders discovered that screws and nails embedded in treated wood would quietly dissolve over time, compromising entire structures from the inside out. So, now we're in a strange place. The natural wood available today rots because it's soft and young. The treated wood designed to solve that problem either isn't durable enough or comes with its own set of risks: chemical leaching, metal corrosion, structural failures. And even after all the chemical intervention, moisture still seeps into the end grain of modern boards like water moving through a bundle of straws. Sunlight breaks down the lignin. Temperature swings cause cracking. Mold finds microscopic pathways. The truth is that modern wood simply wasn't designed to last. It was designed to be produced fast. But the biggest flaw isn't in the wood itself. It's in our philosophy. Modern preservation tries to dominate wood, seal it, force it, poison its enemies, and control its behavior. But wood isn't a material that responds well to domination. It expands and contracts with the seasons. It breathes, it absorbs, it releases. When you coat it in hard, brittle finishes, those finishes crack. When you saturate it with chemicals, it still finds ways to take in moisture. Ancient builders understood something we seem to have forgotten. You don't fight wood. You work with it. They didn't try to overpower nature. They used nature's own tools, resins, oils, carbon, and waxes, to create protection systems that were flexible, breathable, renewable, and incredibly durable. And the most ironic part is that none of their materials were toxic. None corroded metal. None required safety warnings. Yet their wood lasted centuries while ours collapses within years. Once you recognize the difference between fast-grown sapwood and slow-grown heartwood, between chemical shortcuts and natural transformation, you begin to see that the problem isn't your fence, your deck, or your craftsmanship. The problem is the material itself. Modern wood is born fragile. Ancient wood was born strong. And if we want durability again, we don't need more chemicals. We need to relearn what our ancestors already knew. In the next section, we'll travel across Viking shipyards, Japanese temples, and medieval cathedrals to uncover the exact methods they used to create wood that refused to die. To understand why ancient wood survived oceans, storms, and centuries of decay, we have to leave the modern world behind and step into the places where durability wasn't a luxury, it was survival. And the first stop on that journey takes us to the windswept coasts of Scandinavia, where the Vikings built ships that became legends. These vessels weren't preserved by miracle or luck. They were protected by a substance so simple, so natural, yet so powerful that entire industries were built around it: pine tar. But not the thin, diluted varnish-like coatings sold in stores today. Vikings produced pine tar in enormous quantities using an almost industrial process, long before industrialization existed. Archaeologists have uncovered kilns capable of producing up to 80 gallons in a single burn, all from pine roots and stumps rich in resin. The resulting tar was thick, dark, and carried a smoky aroma that signaled a dense concentration of phenols. When brushed onto wood, it didn't just waterproof it. It made it hostile to fungi, insects, and shipworms. These creatures could reduce a ship to mush in months, but Viking tar turned the hull into something they couldn't digest. Their empire wasn't built on brute force alone. It was built on chemistry born directly from the forest. Leaving the Vikings behind, our path leads east to a place where wood was considered sacred: Japan. Here, ancient carpenters developed a method so counterintuitive that anyone seeing it for the first time might think they were destroying the wood. They weren't. They were perfecting it. The technique is called yakisuzi, a method of carefully charring the surface of wood planks until a uniform carbon layer forms. Fire becomes a tool of preservation, not destruction. When wood burns this way, the outer layer of soft cellulose disappears, leaving behind a hardened shell of carbon. That shell repels water. It resists insects. It protects against rot, mold, and even fire itself because the surface is already burned. The planks turn a deep, elegant black, then are cooled, brushed, and sealed with natural oil. With minimal maintenance, yakisugi can last 80 to 120 years, and with regular re-oiling, far longer. It is one of the rare cases in history where destruction truly creates longevity. From Japan, we travel west, far west, to medieval Europe, where craftsmen built cathedrals meant to last as long as faith itself. Their preservation methods were subtle, almost invisible, but astonishingly effective. They relied on boiled linseed oil and beeswax, two substances that, when combined, changed the very nature of wood from the inside out. Linseed oil penetrates deep, soaking into the fibers. As it reacts with oxygen over days, it hardens into a solid yet flexible polymer. It strengthens the wood the way rebar strengthens concrete. Meanwhile, beeswax, mixed into a soft paste with turpentine, is applied as a final surface seal. It fills microscopic pores and creates a hydrophobic barrier that forces water to bead and roll away. Scientists studying masonry repairs in Norway's medieval cathedrals discovered traces of these exact mixtures. Pine resin, tar, beeswax, and mineral fillers, still intact centuries later. Medieval builders weren't guessing. They were material scientists in leather aprons. What's remarkable isn't that these cultures developed preservation techniques. It's that they all discovered different pieces of the same truth. Vikings relied on tar. The Japanese turned to fire. Europeans perfected oils and waxes. Each method solves a part of the puzzle, but none of them alone fully explain the extreme longevity we see in ancient structures. The real power comes when these ideas are combined into a unified system. A system that doesn't rely on a single shield, but on layers of natural defenses working together. Pine tar protects. Oil penetrates and hardens. Wax seals and repels. Each technique enhances the others. And this synergy reveals the lost philosophy our ancestors lived by. Wood should not be smothered, trapped, poisoned, or forced into behavior. It should be strengthened, nourished, and allowed to breathe. Modern construction forgot this, but the old world remembered, and now, after centuries, we're about to bring this forgotten system back to life. Now that we've uncovered the clues scattered across Viking shipyards, Japanese temples, and medieval European workshops, the real question emerges. If each culture discovered a piece of the puzzle, what happens when all those pieces are put together? What happens when you combine the waterproofing power of pine tar, the deep penetrating strength of boiled linseed oil, and the surface defense of beeswax? You get something extraordinary, something that feels less like a modern coating and more like a resurrection of forgotten craftsmanship. And to understand why this combination is so powerful, we have to look closely at what each ingredient actually does. Pine tar, the backbone of this ancient formula, is unlike anything sold in modern hardware aisles. When it's made the traditional way, slowly burning pine roots and stumps in an oxygen-poor kiln, the result is a thick, dark, aromatic resin loaded with phenols. These phenols are the same compounds that protect living pine trees from fungi and insects. When applied to wood, pine tar doesn't sit on the surface like paint. It sinks, it grips, it bonds with the fibers and makes them inhospitable to anything that wants to eat or decompose them. It's waterproof, antifungal, insect-resistant, and astonishingly durable. For centuries, Sweden exported so much pine tar that it became one of the nation's most important commodities. Naval fleets across the world depended on it to keep their ships afloat. The Vikings didn't just stumble into this discovery, they industrialized it long before industrialization existed. But tar alone isn't enough. That's where boiled linseed oil enters the picture, the heart of the mixture. Unlike raw linseed oil, which can take months to dry, boiled linseed oil cures into a solid polymer. This transformation is crucial. When the oil penetrates deep into the wood and hardens, it reinforces the cellular structure from the inside out. Imagine filling a sponge with a flexible resin. It becomes stronger, denser, more resilient. It no longer absorbs water with the same eagerness. This is what boiled linseed oil does. It gives wood an internal skeleton that resists moisture, resists movement, and reduces swelling and cracking. And just like the tar, it doesn't trap the wood, it moves with it, it breathes with it, it becomes part of it. Then comes the final ingredient, beeswax. While tar protects and oil strengthens, beeswax shields. It forms a thin, hydrophobic surface barrier that forces water to bead into tight spheres and roll off before it ever has a chance to penetrate. It doesn't flake like varnish, it doesn't peel, it doesn't crack. Instead, it creates a soft, flexible armor that can be renewed again and again with nothing more than a cloth and a bit of elbow grease. And because beeswax is natural, non-toxic, and breathable, it allows the underlying layers to continue doing their job without interference. When these three ingredients come together, tar, oil, and wax, they don't just create a coating, they create a system. A living, flexible, multi-layered defense that works exactly the way nature intended wood to be protected. Modern finishes often form hard, brittle shells that crack under sunlight or sudden temperature changes, trapping moisture beneath the surface and accelerating decay. But this ancient formula does the opposite. The tar penetrates, the oil polymerizes, the wax repels. Each layer supports the next. Each ingredient amplifies the others. Even more remarkable is the simplicity of the ratio. Equal parts pine tar, boiled linseed oil, and turpentine. The turpentine simply helping everything blend into a workable liquid. And then a portion of beeswax melted in for the final seal. It's a recipe that could have been created in a medieval workshop, a Viking longhouse, or a Japanese carpentry guild. And yet, in a world of synthetic polymers, high-tech preservatives, and specialized coatings, this ancient mixture often performs better. That's the part that fascinates modern researchers. For all our advancements, all our chemicals, all our industrial knowledge, the best solution to wood decay might still be the one our ancestors trusted 1,000 years ago. You don't need toxins, you don't need pressure chambers, you don't need complex coatings with ingredients you can't pronounce. You just need what nature has always offered: resin, oil, and wax, used with understanding, patience, and respect for the material they're meant to protect. And now, after centuries of being forgotten, this formula is returning. Not as a relic, but as a superior alternative. A reminder that some of the smartest engineering ever created wasn't forged in labs, but discovered in forests, and passed down by hands that understood wood in ways we've almost forgotten. In the next part, we'll explore what actually happens inside the wood at a microscopic level, and why this ancient method outperforms many modern treatments without relying on a single drop of synthetic chemicals. To truly understand why this ancient formula works better than many modern treatments, we have to shrink ourselves down, far down, deep into the microscopic structure of the wood itself. Because the moment this mixture touches the surface, something remarkable begins to happen. It's not just coating the wood, it's changing it. Most people never think about what wood really is. To the naked eye, it's solid, strong, simple. But under a microscope, wood looks like an enormous city of hollow tubes, thousands of tiny straws stacked together. These tubes were once highways for water inside the living tree. After the tree is cut, they become vulnerabilities. When rain hits a board, water rushes into these straws, filling them, swelling them, and creating the dark, damp environment where rot spreads like wildfire. Fungus doesn't just eat wood, it colonizes it from the inside. But the moment the ancient mixture touches the surface, pine tar becomes the first line of defense. It flows into those hollow tubes, coating them with sticky phenols that fungi can't tolerate. It turns the inside of the wood from a hospitable home into a hostile wasteland. And because tar is naturally hydrophobic, it slows the movement of water immediately. The wood becomes less of a sponge and more of a shield. Then the boiled linseed oil follows, and this is where the real transformation begins. Unlike tar, the oil doesn't just coat the tubes, it fills them. It seeps deep into the wood fibers, pushed by capillary action into places modern surface sealants can't reach. And once it gets there, it begins to cure. Oxygen from the air reacts with the oil, turning it from a liquid into a solid polymer. The wood fibers become reinforced from within, like rebar strengthening concrete. What was once porous now becomes dense, structured, stabilized. Moisture struggles to find an entry point. Swelling and shrinking, those seasonal movements that crack paint and warp boards, are dramatically reduced because the internal structure is no longer hollow and fragile. Finally comes the beeswax. This is the armor. Once buffed onto the surface, it settles into microscopic pores and creates a soft, breathable film that forces water to beat up instantly. Even UV rays, which break down the surface of untreated wood, are partially absorbed by the dark pigments in the pine tar below. Every threat wood normally faces, fungi, insects, water, sun, has been countered by a different layer of this natural system. What makes this ancient method so superior isn't just the ingredients, it's the philosophy. Modern coatings often create hard shells that crack under stress, trapping moisture beneath and accelerating decay. But this system doesn't fight wood, it cooperates with it. It keeps the surface flexible, the interior reinforced, and the entire structure breathable. Instead of sealing wood like plastic, it protects wood like skin, renewable, resilient, and alive. And the result speaks for itself. Instead of rotting from the inside, the wood ages slowly, gracefully, evenly. It darkens, deepens, becomes richer with time. It doesn't peel or flake, it doesn't blister, it doesn't hide problems, it prevents them. This is the science behind why ancient wood lasted centuries. And in the next part, we'll see how this transformation looks in the real world, and why, once you try it, you may never trust modern coatings again. When you step back and compare the treated wood to a plain, untouched board, the transformation feels almost unreal. One looks pale, dry, vulnerable, the kind of wood that soaks up water the instant a storm rolls through. The other looks alive, rich, warm. The grain glows with depth it never had before, as if the wood finally remembers that it came from a living tree. And the moment you place a single drop of water on its surface, the truth becomes obvious. The untreated board darkens instantly, drinking in moisture like it's been thirsty for years. But the treated wood? The water curls into a perfect sphere and slips away the moment you tilt it. Nothing penetrates, nothing lingers. It simply rolls off, leaving the surface as dry as before. This isn't just a coating. It's not a trick. It's a complete re-engineering of what wood is capable of becoming. Modern finishes often fail because they're superficial. They sit on the surface like a shiny shell. They crack, they peel, they trap moisture underneath, which accelerates the very decay they're supposed to prevent. But this ancient system doesn't suffer from that flaw. The tar and oil become part of the wood, and the wax becomes part of its skin. Everything works together in harmony, just like the materials themselves came from the same forest. And perhaps the most surprising part is how easy it is to maintain. With paint, once a patch flakes, the entire surface must be redone. With this mixture, you simply clean the wood and wipe on a fresh coat whenever you feel it needs renewal. The new layer melts into the old one. There's no scraping, no sanding, no fighting. It's a system that respects time instead of resisting it. And because the finish is natural, there's no fear of harsh chemicals, no toxic exposure, no breakdown that turns your backyard into a hazard zone. You're using ingredients that humans have trusted for 1,000 years. Ingredients that protected ships, temples, cathedrals, and entire civilizations. But the real test of any preservation method isn't what happens in a workshop. It's what happens outside, exposed to rain, sun, frost, wind, and the relentless cycle of seasons. That's why 3 pieces of wood, one untreated, one modern, pressure-treated, and one finished with this ancient mixture, are being placed outdoors for an entire year. No shelter, no protection, nothing but the elements. It's an experiment not to prove a theory, but to reveal a truth we've forgotten. Nature already solved the problem of rot long before industrial chemistry existed. All we have to do is pay attention. And as we wait for the results of that year-long test, one thing is already clear. With these natural methods, you're not just preserving wood, you're reviving a craft. You're tapping into knowledge older than nations. You're creating something built to last. Not for a season, not for a decade, but for as long as the wood itself can stand. So, now you know the truth. The long-lasting wood of the past wasn't a miracle, and it wasn't luck. It was knowledge, simple, natural, and astonishingly effective. Vikings used it to cross some of the deadliest waters on Earth. Japanese carpenters used it to build temples that still stand after more than 1,000 years. Medieval craftsmen used it to raise cathedrals that time itself couldn't break. And after all this time, that wisdom is still here, waiting for us to use it again. Modern lumber may be born weak, but it doesn't have to stay that way. With nothing more than resin, oil, and wax, gifts pulled straight from the forest, you can give your wood the same resilience that protected generations before us. No toxins, no pressure chambers, no brittle coatings that peel away, just a natural, flexible system that works with the wood instead of against it. And remember, the real test has already begun. 3 boards, one untreated, one modern pressure-treated, and one finished with this ancient formula, are sitting outside right now. Sun, rain, wind, frost. A full year of punishment. And when the results come in, you're going to see exactly how powerful this forgotten method truly is. If you found value in this, hit that like button, subscribe, and turn on notifications. You won't want to miss the final chapter of this experiment. And until then, go build something that lasts. Something worthy of the knowledge that survived 1,000 years.